In this video, we're going to be reviewing for exam number 2, which is going to be on this coming Wednesday. And the exam will cover all of the material that was discussed in Chapter 2. And you will have a help sheet that will assist you with some of the problems that are on exam number 2. And what's on the review sheet will be similar to what's on the exam. Alright, so here we'll start off with problem number 1. Here you're given 3 different mappings, and you want to find out which one of those diagrams represents not a function and explain why. Okay, so in this case here, we have mapping A that has these numbers 2, 5, 25, and 3, 12, and 19. In this case, the 2 goes to the 3, the 5 goes to the 3, and 25 goes to 19. Mapping B has 1, 4, 17, and 5, 11, 38. In this case here, the 1 goes to the 5, 4 goes to the 11, and 17 goes to 38. Mapping C has negative 4, negative 3, negative 4, negative 1, and then 1, 3, and 4, where the negative 4 goes to 1, negative 4 goes to 3, negative 1 goes to the 4. So now, in this case, we'd have to pick which one of these 3 mappings represent not a function. And for that to be not a function, you cannot have the x going to 2 different y values on these. So if you look at these 3 mappings, we see that mapping C could not be a function. And here's the reason why. Negative 4 is your x. That's paired with 2 different y values. Negative 4 is paired with 1, and negative 4 is paired with 3. For you to have a function, you cannot have an x value going to 2 different y values. And in this case, C would not be a function. And that's because negative 4 is paired Negative 4 is paired with 1 and with 3. So, mapping C would not be a function. Problem number 2 is to use the vertical line test to determine if the graph below represents a function. And there's the graph right there. Now go ahead and draw that here. So here's my x and y axis. Okay, now that's similar to the graph that's on the on your review sheet. Now, for a vertical line test, for this to pass the vertical line test, that vertical line can only cross the graph at only one place. Okay? So if I draw a vertical line through this graph, here this graph will fail the vertical line test because, number 1, you can see that vertical line crossing the graph at 2 different places. So in this case here, this particular graph is not a function because it failed the vertical line test. Again, for it to be a function, that means the vertical line can only cross the graph at only one place. Here it's crossing the graph at 2 different places. Okay, number 3. And it says here for the function f of x is equal to 3x to the third plus 5x squared, you want to find f of negative 4. Okay, so here our f of x function is 3x cubed plus 5x squared. And I want to find out what f of negative 4 is going to be. Well, we just simply replace each x in the original function with negative 4, because we're finding the value of that function at x equal negative 4. So this will be 3 times negative 4, and that's raised to the third, plus 5 times negative 4, and that's raised to the second. And then we go ahead and simplify using the order of operations here. Negative 4 to the third. You raise a negative raised to an odd power. That's going to be negative. So let me bring down this 3 times negative. Here 4 times 4, that's 16. 16 times 4 will be 64. So I'm going to have 3 times a negative 64. Plus 5 times negative 4, and u squared, that's negative 4 times negative 4. That's positive 16. And then we simplify some more. 3 times a negative 64 will be a negative 192. Plus 5 times 16, that's going to be 80. And then negative 192 plus 80 will be a negative 112. So the value of that function at x equal negative 4 would be a negative 112. Number 4, here you have a piecewise function, f of x equal to negative 2x plus 3, and that's used only if x is less than or equal to 4, or 3x if your x is greater than 4 and less than or equal to 7, or 5 if x is greater than 7. So I'll rewrite that function there. Because you have 2 or more functions over a specified domain. So here we want to find the value of that piecewise function at x is equal to 4. Now in this case here, we're going to use one of these 3 based on this x value. Here the x is 4. So that means it is equal to 4. That means we have to use the negative 2x plus 3. Okay, that's used if x is less than or equal to 4, and in this case, our x value equals 4, so we use negative 2x plus 3. So here I'm going to replace the x with the 4. So I get negative 2 times 4 plus 3. Negative 2 times 4, that's negative 8. And then negative 8 plus 3 will be negative 5. So the value of that piecewise function at x equal 4 would be negative 5. And also we're to find the value of the piecewise function for f of 234. So we want to find out what the value of that piecewise function at x is equal to 234. Well, 234 is bigger than 7. So here, we have to use this number right here, the 5. So for f of 234, that's just simply going to be equal to 5. So the value of that piecewise function at x is equal to 234 would be 5. Alright, number 5. In number 5, you're told to do this. Determine if the function f of x equal to 3x cubed minus 6x plus 1 is even, odd, or neither. Okay. So in this case here, you're going to have to determine whether a function is even or odd or neither by replacing the x with negative x. For it to be even, you must get the original equation back after you simplified it when replacing the x with negative x. For it to be odd, each term must change to the opposite sign after replacing the x with negative x. Otherwise, it's neither. So I'm going to replace each x with negative x. So I'm going to have 3 times negative x raised to the third minus 6 times negative x plus 1. Now, a negative to an odd power will be negative. So here I'm going to have a negative 3 and then x cubed. Minus 6 times the negative x will be a plus 6x and then plus 1. Now compare f of negative x with f of x. You're going to compare those two. Notice only the first and the second term changed to the opposite sign. That last term of a plus 1 did not. It stayed the same. So we cannot say that it's odd because each term in that f of x must change to the opposite sign, and only the first 2 terms change to the opposite sign. It's not even because I didn't get the original function back after replacing the x with negative x. So in this case, the answer for that will have to be neither odd nor even. Okay. On to problem number 6. In this case, you're asked to find the slope-intercept form of the equation of a line whose slope is 5, containing a point negative 8, 1. So here we're going to be writing an equation of a line. Here the slope is negative 5, so that's your m. And the point that the line that we're trying to find has the ordered pair 8, negative 1. So here we have a point and a slope, so that means we have to use the point-slope form of the equation of a line. Okay, so in this case here, this x1 would be negative 8, y1 will be positive 1. So in this case here, our point-slope form is this: y minus y1 equal m times x minus x1. That's the point-slope form for the equation of a line. So here we're going to substitute the x1, the y1, and the m in that point-slope form. So here we're going to have y minus y1 is going to be the 1. That's equal to m, that's negative 5, parentheses, x minus x1, which is negative 8. Now I'm going to rewrite x minus a negative 8 as x plus 8. So I'm going to have y minus 1 equal to negative 5, parentheses, x plus 8. And if you recall, this is what we call point-slope form. That would be your equation in point-slope form. But we want it in slope-intercept form. So what I'm going to do here is just take this part and finish this out completely. So if I bring down the y minus 1, on the right side I'm going to use the distributive property by doing negative 5 times x, which is negative 5x. Then negative 5 times the plus 8, that would be a minus 40. So I have y minus 1 is equal to negative 5x minus 40. And then add 1 to both sides to get the y by itself. That means that y is equal to negative 5x minus 39. So that will be the slope-intercept form of the equation of the line passing through the point negative 8, 1 with a slope of negative 5. Okay. Alright, number 7. It says here, find the slope-intercept form of the equation of a line containing the points negative 3, negative 9, and negative 4, negative 11. So now we got 2 points that we're dealing with. Negative 3, negative 9, and negative 4, negative 11. We only know 2 points. Unfortunately, we don't know the slope. So the first thing we have to do here is find out what the slope of that line is passing through those 2 points. So we use this formula, m is equal to y2 minus y1 divided by x2 minus x1. So in this case here, here's x1, y1. The second point I'm going to label the coordinates as x2, y2. And substitute in that formula. y2 minus y1 is this, negative 11 minus a negative 9. And that's divided by x2 minus x1. x2, negative 4 minus x1, negative 3. In this case here, we're going to do negative 11 minus 9. Now, negative 11 minus 9 would be like negative 11 plus 9, which is negative 2. And then negative 4 minus a negative 3 would be like negative 4 plus 3, which is negative 1. So I got negative 2 over negative 1. Divide that out, that's going to be 2. So the slope of that line passing through those 2 given points would be 2. Now, we can use the slope of 2, and we can use either one of these 2 points here. I'm going to go ahead and use the first point, negative 3, negative 9. In our point slope form, which is in this case, y minus y1 equaling to m, the slope times x minus x1. So in this case here, for that negative 3, negative 9, that x1 is negative 3, y1 would be negative 9. So I'm going to substitute those values into this equation. So we got y minus y1, I'm going to let that be negative 9, equaling to m, the slope that's 2, times x minus x1 that's negative 3. Now, y minus a negative 9, that's the same as y plus 9. Equaling to 2, parentheses, x minus a negative 3, that's x plus 3. So that's point slope form, but I want it in slope intercept form. So I'm going to finish this out by saying this, by doing this. Y plus 9, that's equal to, remove the parentheses using the distributive property, you're going to get 2 times x, that's 2x, plus 2 times 3, that's 6. And then I need to get this y by itself. I'm adding 9, so I need to subtract 9 on both sides. So that means I'm going to have y is equal to 2x, 6 minus a 9, that's negative 3. So the y is equal to 2x minus 3. Okay. All right, problem number 8. You're asked to find the slope-intercept form, the slope and the y-intercept of the line 2x minus 5y equal to 15. So here's number 8. Two x minus 5y equals 15, and here you want to find the slope and the y-intercept. First of all, you have to get this equation solved for y. That means I need to move the 2x over to the other side and get rid of the negative 5 that's in front of it. Let's start off by getting rid of the 2x that's in front of on the left side by subtracting 2x on both sides. So on the left side, I'm going to have a negative 5y, and that's equal to, and I'm going to put the negative 2x in front of the 15. So it'll be negative 2x plus 15. And then, to get this y by itself, I'm multiplying it by negative 5. So what I'm going to do here is divide each and every term in this equation by negative 5. And when I do that, here's what I'm going to have. I'm going to have the y by itself, and then that's equal to negative divided by negative will be a positive, so I'm going to leave that as 2/5 x. 15 divided by negative 5 will be minus 30. So, in slope-intercept form, I'm going to have y is equal to 2/5 x minus 3. That equation is in slope-intercept form, which means the coefficient of your x term is going to be the slope. The number after it is your y-intercept. So in this case here, the slope is this coefficient of x, 2/5. The b, which is the y-intercept, is this number that's added to or subtracted from. In this case, negative 3. You have to remember that slope-intercept form is always y is equal to mx plus b. And this equation is in slope-intercept form. That way you can easily identify the slope and the y-intercept. Alright, number 9. You're going to use the x and y-intercept method to graph the equation 2x minus 3y equal to 6. So here's the equation, 2x minus 3y equal to 6. Now, anytime you want to find the x-intercept, you want to let your y equal 0 and solve for x. Okay? For the x-intercept, you always let y equal 0 and find out what x is going to be. So here, we got 2x minus 3 times the y is going to be 0 minus 6. So here I'm substituting 0 in for y. Here, 3 times 0 is going to give me 0, so I'll be left with only 2x. So it'll be 2x equal to 6. And then to get the x by itself, you divide both sides by 2. That means x is equal to 3. So the x-intercept will be 3. That means that the graph will be crossing the x-axis at 3, which means the ordered pair will be 3, 0, because we let y equal 0. Okay. Now next we're going to find the y-intercept. To find the y-intercept, you let x equal 0 and solve for y. So in this case here, we're replacing the x with 0, you're going to get 2 times 0 minus 3y equal to 6. 2 multiplied by 0 is 0. So you're left with negative 3y equal to 6. And then to get the y by itself, we're multiplying by negative 3, so we divide by negative 3. So that means y is equal to negative 2. So your y-intercept will be negative 2, meaning that the graph will be crossing the y-axis at negative 2. So that ordered pair will be 0, negative 2 for your y-intercept. And then all I need to do here is plot those two intercepts and complete the graph. Now my x-intercept is 3, 0. So on the x-axis, I go to the right 3 and I stay on the x-axis and draw that point. My y-intercept was 0, negative 2. So I stay at 0 but go down 2 on the y-axis. Okay, and those are the only 2 points that I need to construct the graph of that linear equation. So if I connect those points, this line right here represents the graph of the equation 2x minus 3y equal to 6. So here we use the x and the y-intercept method to graph a linear equation. Okay. Problem number 10 is this. Here you're going to use the slope-intercept method to make a graph of the equation y is equal to negative 5/2 x plus 3. Okay, so here's the equation already in slope-intercept form. So the slope will be the coefficient of your x term. In this case, that's negative 5/2. But here I'm going to make the 5 negative and the 2 positive. And then the y-intercept is the number added to or subtracted from x. That's going to be positive 3. So your slope is negative 5/2 and the y-intercept is 3. Now we're going to use those two pieces of information to do the graph of our linear equation. Alright, in this case, the first thing we do here is plot the y-intercept. In this case, that y-intercept is a positive 3, so on the y-axis, we go up to 3 and draw that point. Because that's the point where the graph will be crossing the y-axis in this case. Your slope is a negative 5/2. The 5 will be negative and the 2 will be positive. The numerator in the slope is your rise. The denominator in your slope is the run. Here we use the concept of rise over run to get the second point for this graph. Now, since our rise is a negative 5, we start from the y-intercept of 3 and go down 5 places because it's negative. So from here, I'm going to go down 1, 2, 3, 4, 5 places. The run, which is 2, means I'm going to go to the right 2 places. So from here, I go 1, 2 to the right. And this is the point where this is the other point that will be on that line. So here I started from the y-intercept of 3. I went down 5 places. That's the rise. The run is 2, so you run to the right 2. Connect those 2 points And you'll have to graph the equation y is equal to negative 5 halves x plus 3. Okay. So this is how you graph a linear equation using the slope and the y-intercept approach. Okay, number 11 is the transformation of functions. Here you're given a graph of f of x, which is this right here. You're going to use that to make a graph of g of x is equal to f of x minus 2 and then minus 1 on the outside. Okay, so we need to find out what type of transformations that we're going to have in this particular function g of x. So this is g of x is equal to f of x minus 2 minus 1 on the outside. Now notice we have a minus 2 next to the x. So that tells me I have a horizontal shift. And then I got this minus 1 here as well. That's on the outside. So the other transformation is this. I have a vertical shift. So here I have a horizontal shift and a vertical shift. Now, the one I'm going to have to do first is the horizontal shift. And you have to think of that as the order of operations. You take the value of x, you're subtracting 2 from it, and whatever this is, you're going to subtract that from 1. Well, you're going to do minus 1 from that. So the horizontal shift is done first, then the vertical shift. Okay. Now here I'd like to make a table. The first column is the y is equal to f of x. Those are my ordered pairs. We do the horizontal shift first. And it says a minus 2. Anything horizontal means you have to do the opposite. So the opposite of subtracting 2, we have to be adding 2 to each x coordinate because it's a horizontal shift. Anything horizontal means the x coordinate is changing. And then the last one is the vertical shift. We do exactly what it says. It says minus 1, we subtract 1 from each y coordinate because the vertical shift means that the y coordinate is changing. And here I'm going to give you the ordered pairs for your f of x. In this case, we're going to say negative 4 and 4 as the first ordered pair. And then the other one is this one, 1, negative 4. And the last one, let's say 3, 3, 2. Okay. Now let's find the ordered pairs after doing the horizontal shift. We're going to add 2 to each x coordinate. The y coordinate is going to remain the same. So in this case here, if I add, for this first ordered pair, if I do negative 4 plus 2, that will be negative 2. Bring over the 4. For this next ordered pair, if I add 1 plus 2, that will be 3. Bring over the negative 4. And for this last ordered pair, 3, 2, if I do 3 plus 2, that will be 5. Bring over the 2. So those are the ordered pairs after doing the horizontal shift. Now for the vertical shift, I'm going to subtract 1 from each of these y coordinates here. I'm using these ordered pairs after doing the horizontal shift to come up with new ordered pairs after doing the vertical shift. So I'm going to subtract 1 from each y coordinate because it's a vertical shift. The x coordinate remains the same. So if I bring over the negative 2 here, and if I do 4 minus 1, that will be 3. The next ordered pair, 3, 4, I bring over the 3. Let's do negative 4 minus 1. That's negative 5. And then for the last ordered pair, which is the 5, if I do 2 minus 1, That's going to be 1. This last set of ordered pairs in the final column represents the ordered pairs for g of x. Okay, so in this case, we can go ahead and graph those on a coordinate grid. Okay. Might help if I move this up a bit. Now for the -2, 3. We go to the left 2 and up 3. For 3, -5, we go to the right 3 and down 5. And then for 5, 1 will be to the right 5 and up 1. And I'm going to connect those points in the same way as the graph of f of x. That this point connects to this point. These two connect together like this. So that's what g of x looks like. It's similar to f of x. The only difference was we shifted to the right 2 places and down 1. Okay. So that's problem number 11. Okay, now problem number 12 is finding the domain of the function f of x equal to 2x cubed plus 9x squared plus 7x minus 4, all divided by x squared plus 4x minus 12. Now here we have a rational function here. And we want to find out what its domain is going to be. Okay, so what we're going to do here is take our denominator and set that equal to 0, because we want to find out what values of x that will make this denominator 0. So we take that x squared plus 4x minus 12, I'm going to set that equal to 0. Now that x squared plus 4x minus 12 equal to 0, we can factor that into 2 binomials. So here that x squared, I'm going to break that up as x and x. Then the factors of a -12 that will give me a plus 4x. Well, if I use 6 and 2 and make the 6 a plus 6 and the minus 2 here, 6x and a minus 2x would give me the middle term of 4x. Okay, so I have x plus 6 times x minus 2 equaling to 0. And then I'm going to set each binomial factor equal to 0. So I'm going to have x plus 6 equal to 0, or x minus 2 equal to 0. And then I'm going to solve each one of these for x. So if I have x plus 6 equal to 0, that would mean x is equal to -6. Or if I have x minus 2 equal to 0, add 2, you'll get x is equal to 2. So x equals 6 and x equal -6 or x equals 2, those are the two values of x that will give me a 0 in the denominator. Now on the test you'll be required to write this in interval notation. At least write your domain in interval notation. So I'm going to draw a number line so that way you'll see how to write this in interval notation. -6 will be on the left and 2 will be on the right. Okay. Now at -6 we know we're going to have a 0 here. And at 2, we're going to have a 0 there. So I'm drawing parentheses around the 6 and the 2. Anything bigger than less than negative 6 would work. Anything between negative 6 and 2 would work. And anything bigger than 2 would satisfy that rational function. Okay, so here's the domain for that particular rational function. In interval notation, it's going to be this. From left to right will be from negative infinity to negative 6. And we use parentheses around the 6. Or, and we use the symbol for the union, negative 6 to 2. Or 2 to infinity. Okay. And those symbols means or, which is the union of those intervals here. And all the intervals we use parentheses to show that negative 6 will not be included and 2 will not be included. Okay. That's how we find the domain. Okay, next is number 13. That's the algebra of the two functions. You're given that f of x is equal to 2x minus 25 and g of x equal to 3x plus 7. Here you want to find f plus g of x, f minus g of x, f times g of x, and f over g of x. And that's all there is to it. Okay. So in this case here, let me go ahead and write down those two functions there. F of x is equal to 2x minus 25. And g of x is equal to 3x plus 7. So in part A, we're going to find the sum of those two functions, f plus g of x. Well, f plus g of x, that's simply f of x plus g of x. And in this case, my f of x is given as 2x minus 25 plus g of x, that's 3x plus 7. So all we have to do there is combine those like terms here. 2x plus 3x is 5x. Negative 25 plus 7, that's going to be a minus 18. So the sum of those two functions will simply be 5x minus 18. Now part B is the difference of the two functions. That's f minus g of x. And that's simply saying f of x minus g of x. And in this case here, f of x is 2x minus 25 minus, now notice I'm putting g of x in the parentheses, that 3x plus 7, because I'm subtracting the entire g of x function from f of x. So that's why 3x plus 7 is in parentheses. Now let's simplify this. Bring down the 2x minus 25. That minus sign will make the 3x minus 3x. The minus sign will make the plus 7 minus 7. Now let's simplify this. 2x minus 3x is a negative x, or negative 1x, which you can say negative x here. Minus 25 and a minus 7 will be a minus 32. So the difference of those two functions will be negative x minus 32. Now part C is the product Now on your review sheet, it just says that f times g of x, they use the times sign, but it'd be better to just say fg of x, which is the same as f of x times g of x. So here I'm finding the product of those two functions here. F of x is 2x minus 25. G of x is 3x plus 7. Now we're going to multiply that using the FOIL method. And the FOIL method is this. We take the first term times the first term, that's 2x times 3x, that would be 6x squared. The outer would be these two terms, 2x times 7, and that's a plus 14x. Your inner will be these two terms, negative 25 times 3x, that's a minus 75x. And then the last times the last, minus 25 times 7, that would be a minus 175. And then combine like terms, this will be 6x squared. 14x minus 75x, that's a minus 61x. And then minus 175. And that's the product of f times g of x. And then part D is the quotient of the two functions. That's f divided by g of x. That's simply f of x divided by g of x. The f of x was your 2x minus 25 divided by g of x, that's 3x plus 7. And that's as far as I can go with that problem, because I cannot factor out any common factors that would simplify this in simplest form. Okay, so the quotient of f and g of x would be 2x minus 25 divided by 3x plus 7. Okay. Number 14 is the composition of two functions, f and g. In this case here, you're given f of x equal to 5x minus 23 and g of x equal to 4x plus 1. And here we want to find f circle g of x and g circle f of x. That's the composition of f with g of x and the composition of g with f of x. So here, f of x was 5x minus 23, and g of x is equal to 4x plus 1. So here I want the composition of f with g of x. The composition of f with g of x. Well, the composition of f with g of x, or f circle g of x, would simply be something like this, f of g of x. And in this case, you can see that your g of x is going to be the inside function. So here I want to get f of, now g of x is at 4x plus 1. So I'm going to replace that g of x with a 4x plus 1. So I'm going to be evaluating f of 4x plus 1. Okay. Now, My f of x was the 5x minus 23, so I'm going to rewrite that over here. Now, everywhere I see x in f of x, I'm going to replace that x with g of x. And g of x is a 4x plus 1. So in this case here, this x will be replaced with 4x plus 1, because that's what g of x is. And in the 5x minus 23, that x will be replaced with what g of x is, 4x plus 1. Now I'm going to simplify all of this on the right-hand side to come up with the composition of f with g of x. Using the distributive property, 5 times 4x will be 20x, plus 5 times 1 will be 5, bring down the minus 23, and then 20x, I'm going to bring that down and do 5 minus 23 will be minus 18. So the composition of f with g of x will end up being 20x minus 18. Okay. So this I'm going to put in the pink box to represent the composition of f with g of x. Alright, so that's part A of number 14. Here's part B. The composition of g with f of x, or g circle f of x. And that's the same as saying g of f of x. Now this time your inside function is going to be f of x. And the f of x was that 5x minus 23. So we're going to replace this f of x with the 5x minus 23. So I'm going to be evaluating g of 5x minus 23. But my g of x was 4x plus 1. So, everywhere I have an x in g of x, I'm going to replace it with whatever f of x is going to be. So in this case here, this x right here, I'm going to replace it with what f of x is, 5x minus 23. In the 4x plus 1, that x will be replaced with whatever f of x is, and that's 5x minus 23 here. Now I'm going to simplify all of this here. In this case, use the distributive property. 4 times 5x, that's 20x, minus 4 times 23, that's going to be 92, well, minus 92, and then plus 1. Bring down the 20x. Negative 92 plus 1 will be a minus 91. So the composition of g with f of x would end up being 20x minus 91. So this will be your final answer here for part B. Okay. Problem number 15 deals with the inverse of a function, or finding the inverse of a function. Alright, for the function f of x equal to 9x plus 23, find its inverse, or f inverse of x. So here we got f of x is equal to 9x plus 23. And we're going to find f inverse of x. There was a 4-step procedure that I gave you in section 2.7 for finding for inverse functions, and that will be on your help sheet as well. The first is to replace this f of x with a y. So that means you're going to have y is equal to 9x plus 23. The second step is to interchange the x and y. In other words, this y becomes the x and this x becomes the y. So you're going to have x equal 9y plus 23. And then you're going to solve that equation for y. That means I need to move the 23 over to where the x is and get rid of the 9 that's in front of it. Well, I'm adding 23, so I need to subtract 23 on both sides. Now on the left side, I'm going to have an x minus 23. That's equal to 9y. I still got to get y by itself. It's being multiplied by 9, so I need to divide by 9 on both sides. So that means that y is equal to x minus 23 divided by 9. So that equation is solved for y. Now, the final step is to replace that y with f inverse of x. So f inverse of x will end up being x minus 23 all divided by 9. So this right here represents what f inverse of x is going to end up being. Okay? So that right there represents problem number 15. Okay, the last one, problem number 16, is using the horizontal line test to determine if the graph below has an inverse. Okay, so it's number 16. I'll bring this down a bit. I'll go ahead and do the graph. What I'm drawing is somewhat similar to what's on the review sheet. It's not the best drawing, but we can use a horizontal line test to determine whether that graph has an inverse function. If it crossed the graph at only one place, if that horizontal line crossed the graph at only one place, then we do have an inverse function. So in this case, you draw a horizontal line, it's only going to cross the graph at one place. So we can conclude that this particular graph has an inverse function. Okay. Okay, so that will be basically what you're going to be seeing on exam number 1, which will cover all of chapter 2. Now, I do invite you between now and Wednesday to look over this video as much as you can, and do get help with your SLA facilitator if you need to. And of course, you do have your SLA session on this evening immediately after class is over. So do make sure that you make it to that particular session and ask additional questions if needed. I'll also be available on Tuesday and also Wednesday before the test if you have any last minute questions.